Hey guys, this is Ayush, and in this video and the last video of this section, and in this video I'm going to give you some of the advice for using the support vector machines, and also will distinguish the logistic and the support vector machine. So first of all, without wasting time, let's get into it and start exploring these advice for using support vector machine topic. So first of all, we have to choose our SVM parameters. So first we have our choosing C, and here C is the one by lambda, and here we usually denote C as a regularization parameter. C is a regularization parameter, and it simply equals to the 1 upon lambda. Okay, and the two notes are if C is very large, then we get lower variance and lower bias. And you might be a little bit confused by saying higher variance or lower bias. If I talk about that kind of thing just now, it will be long video. So I want you to go on my previous section where the best practices for machine learning section, and the concept of bias and variance, and the solutions for what the thing had been already taught there. So if you're already coming from there, then you have no problem. But if you're not coming from there and you're not going to understand this, so please make sure to revisit that video and try to understand the topics. So if C is very large, then we get higher variance and lower bias. And if C is small, if C is the regularization parameter 1 upon lambda, then we get lower variance and a higher bias. Okay, nothing to more understand here. It's very simple. The concept you have to understand, and you can revisit the notes of this, in the notes in the description down box below. Be sure to take a look at that after seeing this video. Then we have again a new parameter, which is a sigma squared. This should be squared. Okay, sigma squared from the Gaussian kernel function, or we can say similarity function that we have. In our previous video we had saw that if it is large, the sigma squared is large, then we get higher bias and a lower variance. And again, if you're not getting this, don't worry about it. Please go on to my section of the best practices for machine learning and the last two videos of that section. Then I have if the sigma squared is small, then we get lower bias and higher variance. Okay, these 2 points has to be kept in note, and while working with a support vector machine. Okay, these are my some advices for you. Okay, and you might be thinking, hey, I used the logistic regression and the support vector machine. What is the difference in that? Please give me the advice where we can use logistic or a support vector machine. So here, first of all, we'll talk about this, in what condition we want to use. Okay, so in first thing, if n is large, then we use logistic regression. And again, n here is the number of features, okay, and it is relative to m. It means m and n is something relative, so we can go with logistic regression, and also we can go with support vector machine, but without kernels, or we can say linear kernel, which we have to just draw a straight line and separates this positive and this negative example by drawing just a straight line, or a linear kernel. And then we have our if n is small. Here n again is the features, or columns, and m is medium. If a number of features is very small and the number of training examples is at medium, so my advice is to you is to don't use this algorithm logistic regression. Don't use this. You can use support vector machine. Okay, if n number of features is small and the number of training examples is medium, so go with support vector machine. Now it's upon your choice. You can experiment this out and understand this topic again. Okay, then we have if n is small and m is large, if n is small, number of features is small, and the training examples is large, then what you have to do, you have to manually add the features. Okay, manually add the features, or they can polynomial features, and then use this logistic regression algorithm. Or what you can do, you can also manually add the features and use support vector machine without a kernel or a linear kernel by just drawing a straight line by dividing positive and the negative examples. Okay, and the linear kernel is the linearly separable case that we have seen in our videos. Okay, so I think that's it for this video. This was my last advice to you all, and I think this is the last video, and in the next section we'll come up with the next amazing section and the next amazing algorithm. Okay, so I will be catching up you in the next video. Till then, bye bye.